What is up, my friends? Today we're going to be learning the best way to memorize the blue sheet for chem. I know this has been a daunting task, and hopefully by the end of this video it will be much less daunting. Okay, let's get started. First, we're going to learn how to do it when we have a single positively charged element in the S block. So if you see an element in the S block and it's positively charged and it's only that element, it's so easy. All you do is, it's literally just the name of the element. So here we have a calcium 2 plus. What do you think it will be? Well, calcium is in the S block, and this here has a positive charge, and it's just calcium, which means its name is just calcium. And now we have strontium. Well, strontium is in the S block, and this is just its name, which means it's just going to be whatever charge strontium is. Strontium is in group 2, so it'll have a plus 2 charge, which means rewrite Sr2 plus. So now you know how to do all of these. The only exceptions here is cadmium and zinc, because they're not in the S block, but you still do it using the same method. So just remember, cadmium and zinc, you have to do it this way for them, even though they're not in the S block. All the other ones, well, actually no, aluminum also isn't in the S block. I forgot to make that one red, but all three of those, aluminum, cadmium, and zinc, aren't in the S block, and just make sure you remember, it's the name. Okay, what if they're not in the S block? Well, if you are trying to do the name, or if you're going the other way for an element, and let's say it's not in the S block, but it's a positive charge and it's only that single element, it's the same thing, but you're just going to put a Roman numeral for the charge. Now, this is actually even easier because you don't even need to think about what the charge is. You just look at the Roman numeral. So let's say As3 plus. As is arsenic, and arsenic is not in the S block, which means it's just going to be arsenic 3 plus, and you just take that and you put the 3 in the Roman numeral. Bismuth isn't in the S block. This is saying it's 5, so you just write Bi 5 plus. Very simple, and you now know how to do all of these. So this is basically half of all of them, which is like super legit, right? The only exception here is mercury, and this guy's just weird. I don't even know what's up with it. It says mercury 1, but there's 2 mercuries, and it has a plus 2 charge. So just like remember that, and you'll be good. Also remember, cadmium and zinc aren't in the S block, and they go this way. They don't use Roman numerals. Okay, now, what if it's negative charges? Yes, that was so easy, and that was literally all the positive charges. So you now know, well, actually, that's not. Alright, so, yeah, this is how we do negative charges. Let's say you want to know how to do N3 minus or bromide. Notice in the other one, it would have said bromine, because we were going with the names and Roman numerals, but now we have an "ide." So what do you think this means? Well, it probably means, and it does mean, that "ide" correlates to the negative charges. So if we have a nitrogen, single nitrogen atom that is negatively charged, it will just be nitride. And a bromide, what do you think that suggests? Well, it's a negatively charged bromine. So that means it's going to be Br minus. And you know why bromine is a halogen? So that means that it only needs 1 electron to fill its valence. And when it takes that 1 electron, that's 1 more negative charge, which is why it's bromine Br minus. And now you know how to do all of these. So like, most of these are halogens, but you also have nitride, you have oxide. Those are other ones that aren't necessarily halogens that you indicate by adding an "ide" to the name. And remember, peroxide. So this is a little weird, but not really. All we're saying here is per is another way to say 2. So when you say peroxide, it's just 2 oxygens that are each negatively charged with 2 minus. So we just write O2, 2 minus, and all the other of these are just really easy. Okay, so now it's going to get a little bit trickier, but like not really. So that was all the elements where it's just the element. What if the element is connected to another element? Let's say oxygen. Like all of these are connected to oxygen. So if you have a halogen connected to oxygen, it's super easy. So it's going to look weird at first, but I'm just going to show you the pattern because the pattern makes it very clear. So if you have any element connected to oxygen and the element is a halogen, like all of these are. Let's see, we have bromine and then we have an oxygen. We have bromine and an oxygen, bromine and an oxygen. What's the difference between all of these? You just have more oxygens each time. Since it's a halogen, you always have a -1 charge, but you just gain another oxygen. And the way you convey this is you write bromate. Now, why do you think we're writing bromate? Now, remember how back here on the slide, I just put like 8s everywhere, like here? Well, I put those 8s there because whenever elements are connected to oxygen, we just call it 8. So This is bromate because you have a bromine connected to an oxygen. And because bromine's a halogen, that means it will always follow the pattern that we have 1, 3, 5, and 7. No other Roman numerals will go in these parentheses except for 1, 3, 5, and 7. It's the same thing with chlorate and iodate. You're just going to have a 1, 3, 5, 7 pattern. And for each one, this number right here next to the oxygen just goes up by 1. So you have 1, 2, 3, 4. If you don't feel like thinking about it that way, you could just take the number in the parentheses, add 1 to it, and divide by 2, and that will give you the correlation number next to the oxygen. Or you could just think about it as the pattern of this going 1, 3, 5, 7, and this going 1, 2, 3, 4. I personally think that's a little bit easier, but you know what? Whatever works for you. I think it's a very clear pattern, and remember, this is what you do when you have a halogen connected to oxygen. Okay, now, this thing here, manganate, it's the same exact thing as these. You have a 7 here and you have a 4 there. The only difference is that Pentapara doesn't care about the other versions of manganate, like with other Roman numerals and amounts of oxygen. So, because it's not as easy to exhibit the pattern for, I just stuck it off to the side and made it red. Now, what if you have elements connected to oxygen that aren't halogens? I'm sorry, you actually have to memorize these. I can't figure out any good patterns like these numbers here. You have to memorize them. I looked at the groups, I looked at the periods, I looked at the orbitals. There's really nothing. I mean, you might be able to find something, but I worked pretty hard, you know. So, yeah, you just have to memorize these. I'm sorry. So you have arsenate, carbonate, chromate, phosphate, sulfate, nitrate, borate, and oxalate. Remember, these are non-halogen items connected to oxygen. So what the best way to go about this is to think of this 8 here as correlating to a certain number next to your oxygens. So arsenate always correlates to this 4. For chromate, it's also 4. But for something like nitrate, it's 3, not 4. And then you also have to memorize these charge numbers. Now, the reason why I want you to be able to think of this 8 here in a specific case of the nitrate, meaning there's 3 oxygen, is because if this 8 switches to an ite, then you'll actually have less oxygen. You'll have 1 less oxygen exactly. So before we go over that, I'll come back to that idea, and let's work these examples real quick. So what do you think it means if we have HCO3 minus? So if we go back to here, as you can see, we have actually CO3 2 minus here. And here we have HCO3 minus. Why do you think we have a 2 minus here and a minus here? The answer is because now we have a hydrogen, and hydrogen has a +1 charge. That means when you add to this charge, it just gets rid of it. So there's 1 less charge. So what do you think is... This is the name for another one, right? This is hydrogen sulfate. So because we just stuck hydrogen in front of this, that means this is just going to be hydrogen carbonate, since this was called carbonate. Now, the pattern is that when you add hydrogen in front of it, you literally just stick that here, and remember that affects the charge. So what do you think hydrogen sulfate will be? Well, if we look at sulfate, sulfate is SO4 2 minus. So when we add a... Oops, wait. Where did I go? Oh, here we go. Okay. So, hydrogen sulfate. This is SO4 2 minus. When we add a hydrogen in the beginning, that's just going to kick out the charge. So we're going to have an HSO4 minus. And boom, HSO4 minus. Okay, now that we know those, these are all the examples that use these. So if you are able to memorize these guys, you will know all of these. And this is literally just sticking hydrogen in front and subtracting from the charge. Well, actually, technically you're adding, you're subtracting from the magnitude, but you know what I meant. Now, back to the idea versus 8 and ite. So remember, if you switch something to an ite, it's just going to kick down on the amount of oxygens. And that's why I wanted you to associate 8 with the starting amount of oxygens. Because if you memorize carbonate as starting with 3 oxygens, you'll know carbonite has 2 oxygens. Now, carbonite isn't even on the list, but she only cares about nitrite and sulfite and phosphite. But you'll know that when you memorize nitrate, sulfite, and phosphate, these guys start with 4, and that one starts with 3, which means the other ones will have 3s and a 2. So that's how you know these guys. And then when you have dihydrogen phosphate, remember the dihydrogen correlates to 2 hydrogen, and the phosphate is just same thing here, except now that you have 2 hydrogen, this charge is going to go up by 2. So you're going to have a -1 charge here. Okay. So after you get all of those, you're like basically done. All you have left is these guys. So these are all the losers that didn't actually fit into the pattern. So I just had to stick them here. They're pretty bad, but like, you know, cyanide, at least it kind of sounds like CN. Just go ahead and memorize these. I mean, it can't be that bad, right? Alright, so good luck, and I hope that this made it easier for you. Also, I will include a link in the description to this presentation if it's easier to study from here than the blue sheet.